The massive production of robots in Korea blew up the internet. The production line with realistic humanoids was launched by the Korean company AM Service Gluck, and the robots are designed for animation installation in the Nudak store of the local designer glasses brand Gentle Monster in Hanam, where they will simulate a robotic assembly line. All robot parts were printed on a 3D printer using a large format SLA technology with extremely photorealistic surface treatment. A urethane coating has also been applied to ensure the durability of photopolymer parts. Gluck applied a very high-resolution texture to reproduce even the skin pores on the face of each humanoid, and to get a completely realistic color of the skin required extensive post-processing. Unfortunately, despite being ultra-realistic, robots are still just objects of art and completely non-functional. However, for bringing robotics to the world's attention, they get 10th place in today's list. Previously, Gentle Monster had created a giant robot case for its largest Shanghai house store. Clone Incorporated is a new name among startups that develop humanoid-like robots. Previously, the company was called Automation Robotics. It was under the name that she became famous all over the world, presenting a very realistic robot arm with artificial muscles. The robot arm mimics the human hand on both appearance and principle. She can move her fingers, squeeze them, and tilt her hand, constricting her hydraulic muscles and stretching her tendons. She can even lift a dumbbell weighing 7 kilograms, and all of this is due to the muscle stretching tendons. The muscles themselves consist of stretchable sealed tubes and braided shells. When gas or fluid is fed, the tubes inflate and increase in width. But due to the fact that the fibers of the braided shells are practically not stretched, the construction is reduced in length in the same way as the real muscles are contracted. The reduction rate is regulated by the supply of water or gas in the tubes, and like Elon Musk, engineers hope to eventually create a universal humanoid robot for work and home. It's supposed to be 180 centimeters tall, and its mobility will be provided by electricity and hydraulics, and this is the 9th place in our list. Coming in at number 8, Disney Animatronics. Moving and talking figures in the parks of the company are created on the basis of a single robotic base, the A1000, which is constantly evolving to achieve increasingly realistic movements. But not all of the figures are based on the A1000. So, for Project Kiwi, Walt Disney Imagineering engineers have created a new basis. The robot Groot is unlike any other animatronics, as it's able to move freely without being fixed in a place. Like other Disney figures, Groot is a real interactive. At 75 meters tall, this humanoid robot that's almost completely autonomous, and the cable that you see in this video is used for control, not power. The robot can run for 45 minutes, and its construction gives it incredible 50 degrees of freedom. The robotic Project Kiwi platform required developers to create non-standard high-speed drives with the required torque density so that the robot could perform both fast and slow movements. The creator was also able to integrate onboard computing to support the interactive robot behavior. The developers are planning that, having finished the robot, they'll be able to launch it wandering around the park and interacting with visitors completely on their own. Imagineers also developed Stuntronix, a robot for jumping in the style of superheroes. The built-in touch control allows the machine to perform various flips, turn and pose combinations with repeatability and accuracy. The engineers have developed a 40-kilogram robot that uses sophisticated onboard sensors to make its own decisions in real time, all in flight and at 20 meters of altitude. Stuntronix knows when to bend its knees, perform flips, when to stretch its arms and turn, and even when to slow down the rotation to accurately land, and that is impressive. Seventh place comes in with robots company Robo-C of Promobot. The head of the robot can copy the face of any person. The skin and eyes are already realistic enough, and the robot can copy emotions or express them. Recently, robots have developed hands that can not only gesture, but also perform simple actions, carefully grab objects, or even pour coffee. Each arm of the robot has 8 electric motors, 12 degrees of freedom, and is able to lift a weight of 1 kilogram. And now, the company's working on developing the legs for the robot. The number 6 spot in our list goes to Robot Ameca. The most realistic humanoid robot in the world. Mimics and robot movements are as close as possible to a human. His first public appearance was such a shock that Ameca was immediately recognized by many media as the world's most advanced humanoid. However, the robot designed by Engineered Arts cannot walk or manipulate objects. This is an entertainment platform connected to the cloud. The robot can produce programmed replicas to attract the attention of passing people. Ameca can also be connected to the operator, who will manage his answers when communicating with live visitors to the exhibition or any other event. The robot has a camera in each eye that allows it to track people, their faces, and their actions. The development of artificial intelligence for the robot was left to third-party developers. They themselves are now perfecting its design and hope to teach the robot to walk. Although the practical benefits of Ameca are not worth waiting for, the ultra-realism of its movements and facial expressions will allow researchers to study how humans respond to humanoid robots. Coming in 5th place, the robot Kaleido from Kawasaki Heavy Industries. Debuted in 2016, the robot has evolved to its 7th generation. The 2nd generation approximated the current design of the joints, while the 3rd and 4th generations focused on weight loss and reliability. In the 5th and 6th generation, the Kaleido received a built-in battery and controller, allowing the robot to work independently. The latest version, which is 168 centimeters tall and weighs 54 kilograms, was presented to the public at the 2022 World Robot Expo in Japan, which we discussed at the video. You can see that at the card here. Now, the company is working on a natural and sustainable walking robot and the associated commercialization. Kaleido is positioned as a rescue robot. He can lift any weight of up to 60 kilograms, which gives him the strength he needs to save a person. The robot can also work in hospital industries, performing manipulations even with greater precision than humans. From Kaleido, the company develops Friends, a robot designed to care for the elderly, as the problem of aging populations remains very acute in Japan. The Chinese company UBTech Robotics developed anthropomorphic home robot Walker X. It can bypass obstacles, pick up objects, and communicate with people in 2 ways. First, it has a speech recognition and synthesis system for voice communication. And secondly, there's a big eye mimicking screen at the head of the eye level. There's 28 kinds of emotions built into the robot. Light indicators are also mounted on the housing, which are activated during various interactions. Walker X hands with 5 fingers can lift objects up to 2.7 kilograms and perform tasks using fine motor skills. The robot uses 41 servos to drive and is highly stable due to its dynamic balancing system. Walker X can autonomously move in familiar and new locations based on the simultaneous localization and map construction algorithm. The maximum Walker X speed is 3 kilometers per hour, and the robot uses depth cameras to avoid collisions when moving. Last year, the company claimed its robot was about to become available for purchase, but neither the price of Walker X nor the company's customers are known yet. So despite the wide range of robotic abilities, until we see it in a natural, unstructured environment, it stays in the 4th place. 3rd place, the robot in the iCub Child video developed by the Italian Institute of Technology, which is an open research platform. Recently, the developers introduced the 3rd generation of the iCub 3 robot, which has become larger, heavier, and has received a powerful update, making it a complex telepresence platform with a presence effect. The robot is 125 centimeters tall and weighs 52 kilograms and has 54 degrees of freedom. To use it as an advanced avatar, you need HTC Vive Pro i4 headset, Face Tracker Vive E5, touch and tactile suit iFeel 6, tactile gloves C-Glove DK17, and Omni Virtualizer Elite 28. Altogether, this allows you to copy the movement, manipulation, voice, and even the expression of the face from a person to a robot. In this case, retargeting facial expressions are applied to the eyelid and eyelid state, as well as the user's mouth. The person himself receives an immersive appearance from the first person and a moderate amount of tactile feedback. Today, the robot is the most advanced avatar, but to work with it requires too much equipment inaccessible to the general public. 2nd place, Digit Robot from Agility Robotics. Unlike many humanoids, it's not a research platform. The company aims to create a really useful and universal commercial humanoid, able to keep balance on the legs while manipulating the hands. What can a robot do that is 158 centimeters tall and weighs 45 kilograms? Digit can run at speeds of 1.5 meters per second and can be powered by a battery for up to 3 hours under a light load or 1.5 hours under a heavy condition. He can walk forwards, backwards, and sideways, turn on the spot, climb and descend on the slopes, walk on grass and stones, step over curbs, and squat and stop if he sees a man in the way. In collision, Digit uses his hands and feet to maintain balance. The main problem of the robot is to find interesting applications, as there are simpler and cheaper robots from the simple transfer of boxes in the warehouse. In the last video, the company showed the trailer being unloaded by the robot, but the question is whether the robot can get into the trailer by stepping on it while it remains open, because this moment is not included in the video. But the leadership in agility, maneuverability, and mobility among humanoid robots is still held by Atlas Robot from the research platform of Boston Dynamics. In addition, this year the robot must get hands that can interact with objects as well as humans. Atlas is 1.5 meters tall and weighs 86 kilograms and has one of the most compact mobile hydraulic systems in the world. The robot controls its movement in real time with cameras on the head, in its arms and legs at all 28 joints. And there's also sensors in the pelvis and throughout the body that measure the robot's acceleration, the position of the body in space, and other parameters of interaction with the surrounding world. In the meantime, Atlas locates obstacles, selects footholds, and coordinates body mass transfer during movement, keeping balance. All calculations take place on board the robot. It also knows how to use inertia to save energy. The engineers emphasize that all the robots of the company keep their own balance. It means that if you push any of them, they will react like a person by stepping aside. For more information about how Atlas works, see the link here in the hint. And what humanoid robot would you choose first? Let us know in the comments. Subscribe to the Pro Robot channel, like this video, and don't miss any new episodes from the world of high tech. The first discoveries of this year are Samsung's home robots. The smart and dexterous bot Handy can determine what material an object is made of in order to calculate the force required to maneuver it. The robot can pick up laundry, load the dishwasher, set your table, pour wine, and even bring your drinks. Cameras on the robot's head and limbs are responsible for object recognition. For maneuvering and manipulation, only the robotic arm, which can rotate at 3 points, specifically in the shoulder, elbow, and wrist. The arm ends with a universal grip that works with objects of different sizes and shapes. The robot can move around the room on a platform, turn from side to side, and rise to reach higher objects. And for everyday cleaning, Samsung introduced the JetBot 90 AI Plus robot. It's a vacuum cleaner that uses LiDAR and 3D sensors to clean close to furniture and children's toys. The JetBot's internal camera can be used to monitor pets as well. A recent reality has been a Moli Robotics futuristic robot kitchen project. Not as futuristic as the concept, the robotic kitchen is already quite functional. The system is sold together with furniture and utensils as everything is adapted for optimal robotics work based on proven industrial manipulators. The specially designed gripper can not only use spatulas and ladles, but also, for example, crack eggs, use a blender, or turn on the water. The robot takes ingredients from human-prepared containers. But beyond that, the entire cooking process is fully automated. The robot was trained with the help of a camera recording the cooking process and its verbal description. Breaking down the recipe into simple steps such as stir, flip, salt makes it fairly easy to teach the robot new dishes. The Toyota Research Institute showed its version of home robots not so long ago. The company's engineers are trying to solve two problems: teaching robots to perform everyday tasks around the house, and to overcome the limitations imposed by the unpredictable environment of each individual home. The latter task is partly solved by Toyota's new robot hanging from the ceiling, but it's also unlikely to be implemented in the existing modest-sized Japanese dwellings. Rather, these are developments for future homes and apartments. Toyota is not saying much about the technology behind this robot, but it recently showed off its new lab, which was created to test this very robot. The Chinese Institute of Industrial Technology introduced this year the dual-arm robot system, a robotic system with 2 arms, the total number of joints at 29. This dexterous robot with 5 fingers and 7 degrees of freedom can easily manipulate objects of different shapes and sizes. And they're made of composite material, which makes the robot lightweight, yet durable. This year, Agility Robotics has seriously upgraded its humanoid robot courier Digit, making it completely self-sufficient. All you need to do now is tell the robot the route or the endpoint and it will go where it needs to go, bypassing obstacles along the way. Digit is the world's first commercially available humanoid robot with 2 legs. Currently, the price is unknown, but it's rumored to have 6 figures. The robot can lift weights up to 18 kilograms, gently by bypassing people and interacting with other robots. Digit's main customer today is Ford. The company plans to use the robot for deliveries in conjunction with its unmanned car. The robot uses LiDAR and multiple cameras mounted on its torso to scan its surroundings and quickly detect obstacles. Now, from humanoid robots, let's move on to our four-legged friend robots. A new and rather unusual robot dog was introduced this year by Tencent. The robot dog Max uses the original leg and wheel connection scheme from Tencent Robotics X Lab, which allows him to both walk on four legs and ride on wheels at 25 km per hour. Tencent's software and hardware platform allows the robot to reach its surroundings and control its own balance, as well as plan actions with calculation delays of only 0.3 milliseconds. This robot can also stand up after falling down. Another novelty found was Chinese copy of the Boston Dynamics robot dog. The Weilane company introduced Alpha Dog Robot, which is able to move at speeds of up to 1 km per hour, move with 10 different gaits, and carry a load of up to 5 kilograms. The robot is also able to move autonomously, avoiding obstacles, maintaining balance, and getting up after a fall, and, according to the manufacturer, perform a number of other tasks using artificial intelligence. For example, serving as a guide for the blind, guarding homes, or patrolling a park. It's already sold 2,000 units at a price of just under $2,500. Boston Dynamics itself this year also introduced a couple of new products, specifically a brand new robot for warehouses named Stretch, and an updated version of the robot Spot with an incredibly nimble and smart robotic arm. We talked more about them in an issue about the company's robots, which you can find the link in the video description. An unusual four-legged novelty of the year was Hyundai's Tiger X1 robotic courier for hard-to-reach and remote locations. The robot is dropped off in the night area by drone and then rides on wheels and rises on its feet to step over obstacles if necessary. The top of the robot can easily be replaced with a refrigerator or regular box. The robot has only a prototype so far, but it seems that Hyundai is serious about this technology development and plans to bring to the market a commercial version. We couldn't cover this without mentioning this year's protagonist, the Martian drone Ingenuity. Although it's not exactly a robot, the vehicle opened a new milestone in the history of exploration of other planets, and it's definitely worth mentioning. The Mars drone has already made 4 autonomous flights in the thin atmosphere of the Red Planet, which is only 1% of Earth's atmosphere. It's not equipped with any scientific instruments, except a laser altimeter, a gyro stabilizer, and video cameras. One camera is responsible for navigation, i.e. determining location, directions, and speed. The second camera is a 13-megapixel color camera, and it takes pictures on the surface of Mars. Helicopter communication with Earth is carried out through the rover. The mass of Ingenuity on Earth is 1.8 kilograms, and on Mars about 0.7 kilograms. The helicopter is lifted by air by 2 propellers, each 1.2 meters long and weighing only 35 grams. They are made of carbon fiber and covered with solar panels for recharging the drone. A pair of parallel-mounted propellers rotates in opposite directions around the common axis at about 23 to 2,900 revolutions per minute. By comparison, terrestrial helicopters make about 500 revolutions per minute. Earth-based robotics have made their mark this year as well. Carbon Robotics unveiled a robot for destroying weeds with a laser. This autonomous robot uses computer vision, a powerful lighting system that allows the robot to accurately identify weeds at any time of day, as well as 8 15-watt carbon dioxide lasers. The robot weeds 6.5 hectares a day. Australia is testing an apple-picking robot. The robot uses a combination of cameras and deep learning algorithms to scan trees and detect fruit, which requires it to process information about the shape, orientation, and the branch location. The robot can grip the apple with a specially designed pneumatic-operated soft grip that does not injure the fruit. The gripper can retrieve more than 85% of all apples on a tree, and the robot itself can identify more than 90% of the apples in its camera field of view at a distance of just over 1 meter. The machine can operate in all light and weather conditions and at speeds of 7 seconds per apple. Construction robots also made their mark this year. There were no such spectacular ones as the HRP-5P, but the Bowbot from Australian startup Printstones also looks good. It's an electrically driven robot that reaches its destination on cross-country tracks at speeds of just over 3 kilometers per hour. It can overcome stairs and thresholds, carry loads of up to 500 kilograms, and work for 8 hours without any recharging. Balbot can be controlled from the display on the robot and from a smartphone, as well as by setting points on a pre-made map. The robot is equipped with cameras, its own lighting, and a robotic arm with a range of up to 1 meter and an accuracy tolerance of less than 1 millimeter. The robot arm is designed to handle a variety of tools and can both wrap a screw or weld metal and lay bricks. In the future, after thousands of hours of training and simulation, the robot will be able to work not only with humans, but also with other robots, and this would let the human only supervise the construction. Another major discovery in robotics this year was the microscopic robots capable of becoming medical instruments. The robots created at Cornell University are about 5 microns thick and only 40 microns wide. Equipped with feet the size of a few tens of atoms, they can move with laser pulses and interact directly with human body cells. The robots are resistant to a variety of environments, including extreme acidity and temperatures. But most importantly, it's fast and easy to produce them. In theory, they can both heal wounds from polymer shells around tumors, preventing them from growing. It's impossible to cover all the inventions and technologies of the future that are already being developed in today's one issue. So, subscribe to the Pro Robot channel, turn on those notifications, and don't miss any new episodes. What the new star of YouTube, Twitter, and the US Consumer Electronics Show CES 2022, the Ameca robot, can really do? Does the world's most realistic humanoid robot have artificial intelligence? Who created it, and how and when will the robot get legs? Find out in today's episode. The creators called Ameca the face of robotics of the future. The key idea of the project by the British company Engineered Arts was to create the perfect humanoid body, which will eventually be complemented by a perfect humanoid artificial intelligence. The robot's body is a modular platform that came from another company project called Mesmer. Each Mesmer robot was designed and built based on 3D scans of real people, which allowed the developers to accurately mimic human bone structure, skin texture, and try to reproduce their facial expressions. Engineered Arts engineers, as often happens with attempts to create perfect robots, had to develop most of the components from scratch. So, to control the movements of the robot's head and upper body, they created powerful but silent motors with high torque. Each motor can be controlled independently, and additionally, major parts, including the motors, cameras, depth sensors, lidars, and microphones, can be connected for control via the internet. However, Mesmer robots had one problem: the presence of 22 actuators on the face, only 3 of which were connected to the mouth. This did not allow the robot to reliably reproduce speech. It left the feeling that the robot had just visited the dentist, where it had been injected with an excessive dose of Novocaine. Ameca took the best from Mesmer in terms of design and sensors. The developers have not reported, but apparently the number of actuators on the face has been increased as the robot's facial expressions have become much livelier. In terms of design, the engineers also took a different path. They developed a universal appearance for the robot. No gender, no age, no pretensions to copying human skin. And yet, the robot still became the most realistic of the humanoid ones. The design of the robot is fully modular. You can buy it as a whole or just a head, or buy a head first and then buy arms, or buy another head and easily replace it on the robot without any special required tools. But in addition to appearance, the robot needs intelligence. Ameca needs to sort data from sensors, encoders, motors, network traffic, code, video streams, microphone inputs, physical conditions, and respond to them in real time. It's a complex process, and it's controlled by Tritium's proprietary software. The software allows you to program the control of the robot from anywhere in the world, and moreover, it's designed for non-professionals and it's intuitive. Tritium works just like the 3D software used to control your computer graphics or game characters, providing smooth and realistic motion. The animation for one robot can easily be transferred to another. The software allows you to control your robot's speech, select preset content, create sequences of speech, song, and movement, and edit it all on the fly, as well as working with a library of pre-programmed materials. The company has also developed a wiki guide. If anything goes wrong, the company's engineers can remotely access your robot, run diagnostics, and troubleshoot it. Another plus of Tritium is the ability to work with almost any hardware component on almost any hardware platform. The company talks about all of this openly, but there's something it's kept quiet about. The visitors of CES 2022 were incredibly impressed by the fact that the robot communicated with them, kept up in conversation, and even made jokes. But was this the result of embedded algorithms, or was it controlled by a remote operator in a telepresence mode? The engineers didn't let us know. However, the second option seems most likely to us. Since Ameca positioned as a platform for research and in-house development in artificial intelligence for third-party companies, inside Engineer Arts, there's no talk about artificial intelligence for robots. So what can Ameca actually do? Well, the robot's capable of maintaining eye contact, responding to sudden changes in the environment, being controlled in real time and on the fly, connecting you to a remote conversation, understanding commands in any programmable language, prioritizing when receiving 2 or more commands simultaneously. The robot is equipped with multiple sensors, including cameras, microphones, and position sensors. Visual streams are available from high-resolution head-mounted cameras and overlaid with data from other sensors, and real-time virtual oscilloscopes allow rapid diagnosis and problem-solving. All of the company's robots can't walk just yet, but they move their arms, wrists, fingers, neck, head, eyes, and mouth, and they do it in a very human, real way. They can smile, frown, wink, open and close their mouths, act surprised, disappointed, or even amused. Their purpose is the field of entertainment, marketing, and as a test bed for other software and AI developers. What do you think? Do you think Engineered Arts engineers can teach a robot to walk? How fast can they do it? And will the moving robot be more like Boston Dynamics Atlas or Star Wars C-3PO? Let us know down below. While you're here, subscribe to the channel and stay up to date on the latest news about the world's most incredible robots. The most advanced robot avatars today are being developed in Japan. For example, the Robot T-HR3, introduced by Toyota in 2017. The humanoid robot is able to accurately imitate the movements of a human operator, including walking and fine finger movements. The 1.5 meter tall robot has 32 joints and is able to move very smoothly. The control is intuitive, the range of motion is not less than a human, and the VR helmet on the operator's head allows you to see through the eyes of the robot. The robot is designed to interact with people. The last update of the model was in 2019, but for now, unfortunately, it remains only a concept. Melton is developing technology that would help create cyborgs in the future. These are processing biosignals through the nerves in the human body and developing robotic products that replicate the human anatomy. Now the company has 2 robotic avatars capable of accurately replicating human-like movements. It is Melton A, which arms as precisely copy the structure of a human, taking into account the location of muscles and tendons going to individual fingers. Polymeric elastic wires are used as actuators, pressure sensors, and are also installed in the fingers of robots, and the feedback system provides haptic feedback. The robot is very accurate and very strong. It can hold a 2-liter canister of water with just 2 fingers. A signal transfer from the operator to the robot with a delay of only 0.02 of a second can even be done from a distance of 19,000 kilometers. And Melton B, designed for interested customers for dangerous work in environments with high or low temperatures, with chemical, biological, or radioactive contamination, and even possibly for space exploration. In doing so, the robot can still communicate to humans, but not only with gripping force, but also with texture of the object. And then there's Model H, Teleexistence's robot avatar for shopping and remote travel in Japan. The robot is controlled by a HTC Vive virtual reality helmet and a pair of controllers. The robot itself is mounted on an autonomous wheeled platform, has a pair of arms and a rotatable head, which has 2 cameras for stereo vision. A development of the project was Model T Robot Merchandiser, introduced last year. Store employees can control the robot, which acts as a merchandiser right from home using virtual reality. Video communication between the operator and the robot has a delay of 50 milliseconds, which has almost no effect on synchronicity. The robots are already working in stores of the Japanese chain Family Mart. Now, the company is working to make the robot work faster. But there are robots that are even closer to the human body. For example, Sarcos Robotics is developing and next year is going to mass produce a wearable robot called Guardian XO. The full-size exoskeleton is battery-powered and increases the operator's strength by 20 times, allowing you to lift loads up to 90 kilograms without strain. Guardian XO dynamically compensates for gravity and inertia, detecting the operator's movements within milliseconds. The suit's 24 degrees of freedom ensure free and natural movement, and the hands-free mode allows the operator to leave heavy loads in the hands of robot, freeing their own for demanding tasks. The robotic suit can be put on and removed in just 30 seconds without any assistance. The Guardian XO is the basis for the remotely controlled Guardian XT robot, which no longer needs to be put on itself. It is enough to control it from a safe distance. In the field of construction and repair, humanoid robots look attractive because they can work with the same materials and tools as humans. Take, for example, the HRP-5P robot, the fifth generation of robots from Japan's National Institute of Advanced Industrial Science and Technology. It can pick up and move heavy and bulky loads, open doors, go up and down stairs, bypass obstacles, and use common hand tools. The robot does not need constant supervision of the operator, and can perform a number of tasks independently, for example, move or fasten a sheet of drywall. The ARMR-6 robot from Second Hands Robotics, unlike the HRP-5P, is designed to help humans. The robot must understand commands in natural language and be able to recognize in advance what a human is trying to do and anticipate when it will need the help. In addition, the robot will be able to perform tasks that require a level of precision or physical strength that's unavailable to workers. And, of course, it must do all this autonomously and safely, surrounded by people in an active warehouse. The project is evolving, with the ARMR-6 being tested at Okado's Technologies warehouse last year. Meanwhile, Kawada Robotics' NextAge robots are already at work at the Glory Factory in Saitama, Japan. 19 robots work alongside 300 people assembling machines to sort money for cash registers. The humanoid robots are equipped with cameras in their hands and are capable of performing complex repetitive operations with superhuman power, speed, and accuracy. NextAge can be used without safety barriers, simply by placing it where humans used to work. What's more, multiple NextAge robots can coordinate their movements to work on the same task at the same time. Another helper robot, but now domestic, is the humanoid robot Walker from UB Tech Robotics. The company currently holds more than 700 patents in the humanoid robot industry. Walker is less than 1.5 meters tall and can recognize surfaces, map terrain, and avoid obstacles, walk on stairs, maintain balance under external influences, and manipulate various objects. It responds to voice, maintains eye contact, and can work safely alongside humans. 36 high-performance actuators, a full range of sensor systems, SLAM technology, and a system with elements of artificial intelligence allow this robot to recognize the host, find and track targets, as well as give an estimate of human posture, making the robot one of the most advanced robots in the world. Separately, research humanoid robots are worth highlighting in this issue. They don't yet solve specific tasks and are designed to allow engineers to understand what they can do in principle. The most famous and dexterous, of course, is the Atlas robot from Boston Dynamics. Contrary to popular fears, the robot is not equipped with artificial intelligence, but in dynamic movement, it is unrivaled. Cameras on its head, 28 joints in its legs and arms, and numerous sensors throughout the body help this robot stay in balance when making complex movements. When commanded to do a somersault, the robot relies on a developed library of movement trajectories, but adapts them to the real-world conditions in real time. We talked more about that at the link in the hint, and no, it's not computer graphics, as we're often told in the comments. But the 2020 breakthrough of the American Society of Mechanical Engineers recognized not Atlas, but the Iranian research humanoid Serena 4. The robot is capable of detecting faces and objects, recognizing and reproducing speech, and walking at a speed of less than 1 kilometer per hour. Serena has 43 degrees of freedom, and its arms can grasp objects in different shapes. Iranian engineers are using the robot to research two-legged movement, artificial intelligence, and to attract students to the engineering disciplines. If today's episode makes you think of Honda's Asimo robot, we mourn with you, because the project has closed and we will never see this robot again. What other advanced humanoid robots do you know? Let us know down in the comments. Subscribe to the Pro Robot channel while you're here, and like this video, and don't miss any new episodes from the world of high tech.
The world's first most advanced and famous humanoid robot was not Atlas by Boston Dynamics, but Osimo, developed by Honda. The creation of the robot began in 1986. In 14 years, the company has gone through several stages, studying the types of gait and leg structures of humans and animals to teach the humanoid robot speed and stability. As a result, in 2000, Osimo was presented to the public for the first time, and in 2011, the latest version of the robot was released with the world's first autonomous behavior control technology. The robot not only had the ability to control his body, recognize terrain, and work with certain objects, but also had the ability to interact with people, including understanding their poses and gestures. For 2009, about 100 Osimos were released, but in 2018, the company stopped developing the robot. At the same time, since 2008, the company has been developing a walking assist device exoskeletons, personal mobile devices U3X, Uni-CUB, and the Uni-CUB-B, as well as remote observation robots for operation on the lower floors of nuclear reactors in nuclear power plants. In each of these devices, technology used previously in the Osimo robot was applied. They also became the basis for a new line of Honda 3E concept robotic service robots. 3E-A18 personal companion, 3E-B18 personal mobile device, and 3E-C18 intelligent trolley, as well as 3E-D18 mobile robot platform. Toyota is also active in robotics. The company's most famous robot is the humanoid with the remote control THR3. The robot accurately replicates the operator's movements from a distance of up to 10 kilometers using 5G network technology. Thanks to the master maneuvering system, all parts of the robot body can be controlled by the robot's own movements. In doing so, the operator controls the coordination and force of the robot's contact with people and objects via feedback technology and sees everything with its eyes via a headset. The robotic is flexible and smooth in its movements. The real star time in robotics for Toyota was to be the Olympics in 2020 in Tokyo. The company's Olympic and Para-Olympic robotic mascots, Fermiratob and Samedi, were to be welcomed to the public, while the THR3 and TTR1 robots were provided a remote presence for those who could not go to the event live. The H5R, human support robot, and DSR, delivery support robot, had to take care of the spectators' comfort in wheelchairs, guide them to their seats, and after a selection of light snacks and drinks, while the FSR field support robot had to become an assistant judge. Equipped with a fully automatic control system, the FSR can collect sports equipment used in the competition. Toyota also sells Kirobo mini robots, capable of communicating not only with a person, but also the company's car and smart home. In the top 10 manufacturers of industrial robots in the world, 5 companies from Japan, and the bottom of them is Yaskawa. It manufactures about 40,000 robots per year, most of which are manufactured under the Motoman brand. Its range of robots includes robots for welding, assembly, cutting, painting, warehousing, and research, as well as ready-made solutions for customers' needs. In 2015, the company celebrated its 100th anniversary, in honor of which it transformed its headquarters in Katayushu into a robot village open to the public. The company has many innovations on its account. For example, in 1994, it released the world's first robotic controller, capable of synchronously controlling 2 robots, and in 2007, it saw the world's fastest arc welding robot, the Motoman SSA 2000. The company also manufactures collaborative robots for working with people. For example, the Motoman HC10 is capable of performing a wide range of tasks, lifting loads of up to 10 kilograms and working within 1.2 meter radius. But the main thing about this robot is it can be controlled manually, without programming, which allows you to quickly integrate it into any process. The company has also a biomedical robot. Motoman CSDA-10F is a two-handed robot system capable of working accurately in a laboratory environment with any standard laboratory equipment. The robot is easy to train and can be used in pharmaceutical, clinical diagnostics, research, and development of new drugs. For example, the AlpStory startup embodies the success of business models producing the personalized cosmetics and therapeutic processes using the Motoman CSDA-10F. Another Japanese industrial robot manufacturing giant is Fanuc. Its operations are worldwide, including the Tesla factory in Fremont, California. The M10IA-12S robot is one of the most popular robots in the world, featuring compactness, speed, and agility. According to some estimates, the total number of M10IA-12S robots in the world is about 2 million. The Learning Vibration Control training system enables the robot to increase its own productivity. Another outstanding Fanuc robot is the M2000IA-2300. It's one of the largest robots in the world. The 2300 marked with the payload of 2.3 tons. It's capable of lifting and turning very heavy objects without losing speed or accuracy to a height of almost 4 meters. The robot is also capable of lowering the lifted load to a precisely defined location. The M2000IA-2300 robots are installed on Boeing, BMW, Saab, Land Rover, and others. Fanuc arc welding robots feature Fanuc IR Vision system, which allows them to determine the type of part, its position, as well as performing post-welding inspections. Unlike the previous two companies, Kawanda Inc. describes humanoid robots for industry and other applications. The best known is NextAge, an industrial humanoid robot capable of interacting with other robots as well as with humans. The robot manipulators are equipped with an image recognition system. It is able to perform ordinary mechanical work, tighten screws, build on a machine, assemble structures from parts, and even make coffee. It can be used as a front loader to pick up, transport, and store small objects. NextAge has been used in the production of various machines since 2009. In the Japanese factory of Glory Ltd., they are engaged in the assembly of ATMs and automatic payment terminals. The machines work side by side with people without creating any danger for them. NextAge can also work as a barista. The price of a robot is more affordable than Spot, from $62,000. There's also an open-source research variation of the robot. In addition, this company, with the support of the National Institute of Advanced Industrial Science and Technology, was implementing humanoid robotics project funded with the Ministry of Economy, Trade, and Industry of Japan. The HRP 1, 2, 3, and 4 robots were based on the P-Series robots purchased from Honda, which were intermediate robots before Asimo. As part of the humanoid robotics projects, the robots learned to stand up on their own, walk narrow paths, and work with some tools and objects, but not on their own, and nor were they independent. In 2018, without Kawanda's participation, AIST created a more autonomous construction robot, HRR-5P, based on these developments, which was already capable of performing a number of tasks independently. If you want to learn more about 5 more Japanese companies and their incredible robots, like this video and we'll make a second part to this review. Subscribe to the Pro Robots channel and watch and playlist reviews of the coolest robots around the world and the latest technology news.
The love of robots in Korea begins in educational institutions. Since kindergarten, Koreans are surrounded by robots. They play with them, give them educational lessons, and even participate in their upbringing. And in the institutions, having grown up with a pop culture of robot superheroes helping humans, Koreans start designing robots themselves. For example, the DRC Hubo humanoid robot transformer, developed by the Korean Advanced Institute of Technology and Science, KAIST for short, won the DARPA Robotics Challenge in 2015. The KAIST team won first place and took home the grand prize of $2 million. The same institution also developed a robot designed for rescue operations or helping people with disabilities. Interestingly, the institute has been operating for many years under a boycott by artificial intelligence researchers from nearly 30 countries. The boycott stems from the fact that its robotics lab is collaborating with the country's leading defense company, which could lead to the creation of killer robots. Other KAIST developments include all-weather tracked all-terrain vehicles capable of traversing steps thanks to an unusual design. There's also an in-house designed LiDAR and robotic arms that replicate the structure of human arms. The robotic arm is based on a 2-speed transmission mechanism and a tiny force sensor for tendons, which serve as twisting and untwisting threads. The thin, light, and strong hand can exhibit impressive strength in each of its fingers, as well as overall strength and speed in grasping objects. But humanoid robot giants aren't just being developed at the Institute. Hankook Mairi Technology showed off its 4-meter Method 2 robot a few years ago. The giant manned robot was like a human, but makes the ground shake under its own weight. The pilot's arm are connected with 2 mechanical levers that quite accurately transmit motion to the robot's huge aluminum arms. At the factory, Method 2 is powered by cable, capable of moving up to 1.5 tons but is still forced to walk in a walker suspended from metal cables because it has problems with its own weight distribution when walking. Korea has also developed its own rocket engines, a hybrid one at that. The startup InnoSpace produces small engines that use a combination of solid fuel and liquid oxidizer. Such engines are considered safer and more economical than rockets powered by traditional single-state fuels. Compared to competitors in small rockets, InnoSpace rocket engines have about 2.5 times the range, up to 500 kilometers. At first, the startup plans to launch nano-satellites weighing up to 50 kilograms on its rockets by 2024, micro-satellites up to 150 kilograms, and by 2026, mini-satellites weighing 500 kilograms. Then, it will come to spaceships with people on board. There's also robot dogs of their own. Aiden Robotics asserts that it creates robots that are not only much cheaper than the Boston Dynamics machines, but will also work better in the domestic market. It's not entirely clear what they mean by that, but the startup is developing a four-legged robot dog with multi-axis force sensors and robotic arms that can independently detect and evade objects or people. The company's engineers are also working on a versatile robotic gripper that can pick up both heavy objects and delicate objects such as berries. Aiden's RoboPasses use articulated actuators with 12 degrees of freedom that have built-in torque sensors. Full torque controls allow the robot to walk on uneven surfaces as well as carrying or dragging quite heavy loads, including, for example, a car. Advanced software is crucial to creating autonomous robots, and local developer Playf aims to solve this problem. The startup is developing software with elements of artificial intelligence, which it calls the Iron Man analog of Jarvis. Right now, the startup's algorithms allow any industrial robots to recognize and sort objects, but in the future, the developers plan to let robots do everything for people, like Tony Stark's Iron Assistants. Angel Robotics is a Korean startup that develops exoskeletons. They helped the national team win gold and bronze at the World Kibathlon event in November 2020 with mechanically powered exoskeletons. The wearable robot allows people with total lower limb paralysis to walk at the speed of a healthy person, namely 2 to 4 meters per second. To date, this is the highest speed recorded in the world for people who are paralyzed below the waist. Military robots are created not only at CAST but also at the Institute of Industrial Technology. Here, they're trying to replicate the walkability, stability, and endurance of the Big Dog robot from Boston Dynamics. The hydraulically powered Dogma robot must be able to get coordinates specified to it, independently assessing the terrain and selecting its gait. The Institute also working on a robot capable of performing the functions of border guards, scouts, and guards in unmanned mode. The robot is equipped with cameras, a microphone, and a speaker to check communication and verify the identity of suspected intruders. But it's also possible to install a machine gun and a wide range of other weapons. The robot can reach speeds of up to 50 kilometers per hour and can cover 20 to 30 kilometers per shift, depending on the complexity of the road conditions. By the way, all 6 wheels of the robot can rotate 360 degrees. There's also examples of the real use of artificial intelligence for military purposes. South Korea's northern borders are guarded by SGR-A1 clock robots, automated machine gun turrets developed by Samsung and controlled by AI. Samsung generally develops many projects in the field of robotics. For example, GEMS Wearable Robots, a system that helps people with weakened leg muscles, for example, after injuries. The company also has conventional bots for retail, from shopping malls to restaurants and stores. But there's other much more interesting concepts like the Bot Chef. It's an autonomous, intelligent kitchen capable of cooking a wide variety of dishes. An overhead camera sees the entire work area and recognizes items by markings. And nimble robotic arms manipulate all available cooking utensils to prepare dishes according to laid-down recipes. There are other home robots too. For example, BotCare, which uses AI to recognize and understand the host's behavior to become a better robotic helper and companion. It can remember your schedule and habits, remind and organize your calls, and run other errands for you. There's also a real robot butler, Bot Handy, which is an autonomous mobile robot with a manipulator and artificial intelligence. The bot can recognize, grab, pick up, and place items anywhere you need help around the house. The robot's capable of doing complicated things like cleaning clothes and sorting dirty dishes and then loading them into the dishwasher. Another South Korean giant, LG, has been mass producing and employing more than 10 kinds of service robots for quite some time. Since 2017, for example, the company's robots have been working as guides and cleaners at the country's airports. Other bots from the company help medical staff at the Seoul National University Hospital. LG robots can easily be found in restaurants, cafes, stores, and hotels. They move around on their own. They ride the elevator, and they go around obstacles and stop if a child jumps out in front of them, or even if a small object falls. Robo-carriers are actively working on sidewalks in the city, and from 2023, delivery robots will be able to move on public roads. In South Korea, robots generally do more work than people, and considering that, on average, according to industrial robot manufacturers, one robot replaces 15 people. Last year, the country regained the title of the world's most robotic company, with nearly 1,000 robots per 10,000 workers. Korea has its own serious manufacturers of industrial robots, such as Doosan. And since Doosan's multidisciplinary, collaborative robots are capable of doing everything from making coffee to assembling cars, the company does not limit itself to other interesting projects. For example, Dr. Presso is a modular autonomous cafe capable of serving customers around the clock. The robot barista can make 15 kinds of hot and cold coffee and even closes behind itself all the lids on the dishes to protect foreign objects from falling inside. Another example is the Nina robot, which stands for New Inspiration, a New Angle. The robot camera can professionally shoot video from the most amazing angles and without human commands. The novelty was awarded an award for innovation at the Consumer Electronics Show in the US. There's also solutions for smart farms. However, they're still at the stage of prototyping and creating software. And at GITEX Global 2021 in Dubai, Doosan Robotics presented a robotic surgeon. It can perform laparoscopic surgeries and is half the price of existing analogs. The robot's expected to receive regulatory approval this year. Neuromecha is another manufacturer of inexpensive and easy-to-use collaborative robots. But what makes the company interesting is that it supplies robots as a service, actually inexpensively supplying a ready-made robotic solution for any or even the smallest business, whether it's a tire shop, a coffee shop, or a fast food joint. It's also possible to order a full simulation of any production facility involving robots. These services are provided by the startup Easy Robotics. Its product, DMWorks, is a manufacturing simulation software that allows users to create and simulate device movements and logical sequences in the manufacturing process. All in all, instead of worrying about the end of the world, technically advanced and pragmatic Koreans are figuring out how robots can improve their lives here and now. Do you agree with this type of tech evolution? Let us know in the comments below.
The Chinese Al-Nemo team has developed one of the first home robots in the world. The startup, which has so far earned more than $10 million, today creates a next-generation robot that will integrate a number of consumer devices and be managed remotely through a proprietary mobile application. Albo, based in Beijing, is a rising star in the bot industry. The company's robots can work with people to perform complex tasks in warehouse and production. The company's flagship robotic arm costs a relatively modest $18,000 and is great in demand in China and the US. Albo robots can dance, draw, massage, and help artists create works of art. Borns Robotics is a startup that creates medical robots and robotic tools for surgery that allows doctors to perform very complex, risky operations with unprecedented precision and accuracy. This year, the startup received $18 million to complete the first clinical trials and a large-scale development of the BM-R5, its next-generation automated surgical system. These robots will operate on people around the world. Chinese robotics company Geek Plus manufactures a variety of robots for logistics, offering customers not only automated warehouses, but also fully self-contained throughout the entire order cycle. The latest innovation from Geek Plus is a parcel sorting robot. This technology has already become an integral part of the development of e-commerce companies such as Alibaba and Taobao. MakeBlock is a startup from the Shenzhen creating a new generation of educational robots for children around the world. MakeBlock started as a robotic engineer, but then focused on programming education. The company is rapidly developing and has already agreed to partner with Microsoft to induce its robots, not only to school children, but also to university robotics students. Rokid is a company that produces a wide range of intelligent devices and robots, from Rokid alien voice assistants, Rokid MI speakers, to Rokid glasses, Rokid Vision augmented reality glasses, and all this with artificial intelligence. The company has made many developments in the field of virtual and augmented reality, smart wearable devices, and artificial intelligence. In addition to its powerful technical base, this project has solid funding. UBTech, one of the world's leading robotic companies, specializes in creating humanoid robots, both commercial and consumer. The most famous is the Walker Butler, the latest model of which was presented at CES 2019. The robot received hands and learned how to open doors and soda. The robot can communicate, recognize objects, move in a controlled environment, and perform many manipulations. The company's second famous product is its home robot companion, Alpha One, which can dance, even has a team, as well as play football. Also, very recently, UBTech has released a robotic designers for children, the Firebot Kit and Champbot Kit. Both designers are very decent and suitable for both robotics and programming training. UCAN Robotics is a company that develops an underwater robot for shooting HD video and exploring the world's oceans. The drone UCAN ROV drone, with built-in 4K video cameras and a battery that allows the drone to work for up to 5 hours consecutively, can track underwater objects, including the diver himself. Also, the underwater drones are produced by the Chinese company Chasing. Its lineup includes both a drone for professional shooting underwater in 4K to Gladius Mini, a drone for high-quality amateur shooting Dory. It's worth mentioning in this video that DJI is also a Chinese technological company, but it's worth telling you about in a separate video. Or is it? What do you think? Let us know down below and subscribe to the Pro Robot channel to be the first to know of all the new robot technology from around the world. When talking about smart robots, the first thing is to understand is that machines, like humans, have two types of intelligence: motor intelligence and cognitive intelligence. Cognitive intelligence allows you to recognize a problem and figure out how to solve it. Motor intelligence allows you to control your body without having to think about walking or jumping, manage your energy by calculating the strength for a particular action, and perceive real-time information to interact with your environment. Boston Dynamics' approach to its robots is, first, to create a motor intelligence that is reliable and workable in all circumstances, then go on to create a cognitive one which will make it easier to plan the robot's actions based on advanced motor intelligence. And then, the engineers have to make the motor and cognitive intelligences work together. For example, in this video, Atlas uses its real-time perception to locate obstacles, select foot support locations, and coordinate the transfer of body weight as it moves while keeping its feet on the ground. Atlas perceives its surroundings as you currently see them on the screen. As it moves, it decides if there is an opportunity to avoid an obstacle and adjust its body position based on the calculated trajectory, but taking into account the feedback from the calculated actions. This result is ensured not only by the software and controls, but also by the design of the robot. The most important part of the robot is a very compact hydraulic power unit weighing only 5 kilograms and 5 kilowatts. It's designed by Boston Dynamics and houses the electric motor, pump, reservoir, battery, several filters, electronics, and a cooling system, all of which is housed in a rugged case and placed right inside the robot. The unit is powered by a lightweight 1400 watt-hour battery and is also designed by Boston Dynamics. The rugged housing won't allow the battery to catch fire if the robot was to fall. The company's engineers had to create a lot of things from scratch, and the spatial design of the frame and legs, which had to be light but very strong, and lightweight hydraulic servo valves of special design. A 3D printed hydraulic manifold with 18 valves, as well as printed fittings and hoses to make it as light as possible. The robot monitors its movements in real time using cameras located on the front of its conventional head. The robot's arms and legs have a total of 28 joints. In the pelvis and all over the robot's body, there are sensors that measure the robot's acceleration, its position in space while moving, and other parameters of its interaction with the world around it. The robot actively balances while walking, running, and doing tricks. It knows how to use the force of inertia to save energy. It can survey the terrain and it senses through sensors in its feet while adjusting to the force exerted by its feet onto the ground. Each jump or somersault requires a massive calculations from the robot. Engineers emphasize that all of the company's robots keep their own balance, and that means that if you push any one of them, it will react like a human by taking a step to the side. Atlas doesn't choose what it does. The commands are given by the operator. He presses buttons telling the robot to jump here and do a somersault there or turn around, but it's up to the robot to figure out how to make this particular movement given the conditions from its current position. So, how does it do that? Let's take a look at how the controls for the robot are programmed and created. By the way, don't forget to subscribe to the channel and know everything about the coolest robots in the world. Boston Dynamics has an approach to programming that's based on a predictive model. This means that the researchers use all the information they have about a robot to develop algorithms that control its dynamic performance. They also do a lot of pre-computation of everything the robot can use to perform a particular task. For example, a whole library of pre-calculated motion paths is created for Atlas. The robot control system takes the information about the pre-calculated trajectories and adapts it to the current conditions that the perception system is collecting. Atlas selects a trajectory from the library that's suitable for the task and then changes it according to the current conditions. So far, the robot can't learn new movements on its own, based on previous experience, but can act strictly on the programmed models. Although Boston Dynamics engineers are probably already thinking about self-training. As for the robot's perception system, Boston Dynamics uses a geometric segmentation. The robot literally breaks down the environment into local areas with simple geometric shapes. These shapes become inputs into the planning system, which think through a few steps ahead so the robot can keep its balance by using arms and legs correctly. But this information is not static. It changes in real time, allowing the robot to better adapt to conditions and avoid pre-calculation errors. A big plus for Atlas the robot is that once it learns to do a somersault, it can do it the exact same way with the exact same efficiency day after day. This has helped engineers create an amazing video of dancing robots. To teach Atlas to dance, the company brought in a choreographer. The preliminary work was to determine what ideas a real dancer could try to implement with a robot. The engineers used simulations to quickly go over movement concepts that the robot could execute. The ideas were first implemented in the simulation. They made adjustments and then tried on the robot. Engineers described this process as a conveyor belt, when a lot of different movements were described by a lot of input and implemented by the robot. In the end, it took several months of hard work to create a great dance. Boston Dynamics admits that the reliability of Atlas robot can't yet be compared to that of Spot. Its maintenance takes a long time, but engineers are not stopping anytime soon. So, be on the lookout. Soon Atlas will be able to work with its hands. Not just moving boxes or balancing with hands, but to fully perform complex tasks so that the robot's hands become as dexterous as its legs. Subscribe to the Pro Robot channel, like this video, and let us know down in the comments, what do you think Atlas should learn to do first?
Today, we are experiencing a real boom in artificial intelligence and technology. This leads many scientists and engineers to consider the emergence of universal humanoid robots as the next logical step. And indeed, machine vision is already approaching human vision, and in a number of scenarios, it's vastly superior. Clever robotic hands can act and feel no worse than human hands. Robots on legs perform at the level of gymnasts, and artificial intelligence can defeat people in Go and Dota, exclusively human games. It would seem that all of this is ready to combine together. And when it does, what happens? Let's talk about that today. It's a fact, many robotics teams are working on human-like robots right now, each of them developing their own design, but more or less repeating the structure of the human body and adding a number of skills to their robots. But there's not been much progress. And then Elon Musk comes on stage and says that in 2 years, he can create a versatile, functional humanoid robot that can go to the store for you, buy your products, or do a little maintenance on electric cars. Many have taken this as a joke or a publicity stunt, but Musk claims that they are all very wrong. "I was surprised that people did not realize the scale of the program of robots Optimus," said Musk at a press conference. "The importance of Optimus will become evident in the coming years. Those who are discerning or listening attentively will realize that Optimus will eventually cost more than the automotive business, more than the FSD." Additionally, on September 30th, during the next Tesla AI Day event, the working first prototype of the robot Optimus will be shown. What will this robot look in reality? What will the technology be like that Tesla helps create? And how all of it will work according to Musk in today's episode. Let's start with the most interesting part. Why did Elon Musk decide to focus on the production of humanoid robots? The answer is simple. Musk always looks to the future as he sees it. When he creates SpaceX, he already represents the colonies on Mars. For him, the future of mankind is self-governing cars, interplanetary rockets and interfaces, and brain machines expanding our capabilities as humans. This is a world where technology is the savior of humanity, and in the future, energy will be cheap, affordable, and sustainable. Humans will work in harmony with intelligent machines and even merge with them, and we will become an interplanetary species. Musk imagines that humans will eventually surpass our evolutionary heritage with technologies that transcend human or even superhuman capabilities. But before technology can become superhuman, it must become human, or at least be designed to thrive in a man-made world. To do this, Musk develops very specific, basic, interconnected areas of technology, things like sensors, actuators, energy and data infrastructure, system integration, and significant progress in computing power. Together, they provide a set of tools for his vision of the future. So what kind of robot is Elon Musk planning to build? The humanoid robot called Optimus, or Optimus Subprime, as Elon jokingly calls it during an interview, has now become Tesla's top priority project and should become more significant in the future than the automotive business. According to the concept, the robot should be 172 centimeters tall and have a mass of 57 kilograms, which roughly corresponds to the human parameters of the average person. Engineers plan to achieve this growth to mass ratio by using innovative lightweight and durable materials. It's also possible to assume that developers, like Boston Dynamics Atlas Robot, will have to design many elements of the design from scratch, taking into account their 3D printing on a 3D printer. We've already explained how Atlas was created, and the elements of its hydraulic actuators, and how elements of its hydraulic actuators were incorporated into the design of the printed foot parts to minimize the weight of the robot, and you can see that issue by following the link right here in the hint. Optimus should be maximally similar to the person, including hands with 5 fingers. The engineers estimated that 40 electromechanical actuators would be enough for the robot joints to move. They will be sensitive to the efforts being made to achieve balance and to move quickly and clearly. By the way, the robot will move at speeds of 8 kilometers per hour, which is quite a lot for a humanoid in an unstructured human environment. And by doing this, Musk promises to limit the robot's capabilities so that man could run away from him and even win in a fight. But the robot will not be weak, otherwise its functionality is lost. Optimus will be able to lift a weight of 5 kilograms on the extended hand, and with both hands carry a load of 20 kilograms, and lift an object of 68 kilograms. The head of the robot will include a large screen to display information, and it will be possible to communicate with it in a natural language, giving commands by voice. At the same time, the robot will be so smart that step-by-step instructions won't be needed. It will be smart enough to hear the command and do the task. In order for the Tesla robot to feel the environment, the robot's head will be equipped with the same autopilot cameras that are built into Tesla cars. The robot's perception will be the same as that of electric cars, and this is a 3-dimensional vector space that's created as the environment is perceived through 8 chambers. These 8 channels are adjusted and then merged into a single virtual model of environmental prediction, which gives computers an auto vision of the world in which it travels from a bird's-eye perspective. It's kind of a 3-dimensional recreation of a local space in Tron style. These bots will run through a computer interface of full Tesla self-driving, the same as the Tesla Model 3, X, S, Y, and Roadster. The humanoid artificial intelligence will draw on Tesla's experience in the field of neural networks for cars in the advanced supercomputer company Dojo. With Dojo electric cars, companies are able to recognize the surroundings, understand the voice commands, and make decisions needed to achieve their goals. But moreover, Dojo allows cars to continuously improve their behaviors to minimize the chance of error. Whether advanced processors will help do the same humanoid robot is still a big question. The robot's brain will be enclosed in a fully autonomous computer, and its control will be decentralized for greater security of both the client and his personal data. It's also worth noting, these robots can't be transformed into a single army of bots. Optimus will use video neural network planning, neural network planning, labeling, modeling, and other tools to help it perform everyday tasks efficiently. Musk recently stated on Twitter that Tesla can go even further and focus on Common Artificial Intelligence, or AGI. A quote from Musk said, "Tesla artificial intelligence can play a role in AGI given that it trains against the outside world, especially with the advent of Optimus." Musk, on the other hand, stated in a presentation that the robot would never receive common AI to avoid endangering humanity. Tesla and SpaceX have complicated the relationship with artificial intelligence. Musk was the co-founder and main sponsor of OpenAI, a non-profit research group on artificial intelligence, which aims to ensure that AI benefits all of mankind. In 2018, he resigned from his position in the group, citing a potential conflict of interest with Tesla's own efforts at artificial intelligence. A number of experts believe that Musk ultimately wants to turn Tesla into an AI and robotic company, and he only needs machines to make money for the business. But how real is this? This is a very, very big question. Let's not talk here about the possibility of creating a common artificial intelligence, which we've discussed in detail in the release you can find here at the hint. Let's focus on robots. Despite the optimistic market outlook, which is growing steadily, robotic companies don't seem to be thriving as they expected at launch. In 2018, Rodney Brooks founded the well-known robotic company Rethink Robotics, which went bankrupt due to a lack of funds. A year later, Anki, a robotics company based in San Francisco, was forced to close after 9 years due to bankruptcy. Soon after, Jibo of MIT was very popular for its exceptional homemade robot, which went belly up, even raising more than $70 million in investments. Google sold Boston Dynamics because the company cost $50 million a year but didn't generate any revenue. Then SoftBank got rid of the developers of the Robot Atlas, as it realized it could not earn money from them. However, Musk is able to make money on his dreams as well as to captivate investors with his ideas. In addition, it's possible that because robots are now actively involved in space research, the creation of TeslaBot may also be related to plans to conquer Mars, and thus SpaceX might be involved in the future development, although not before Starship is started and regular runs are set up. Given Musk's mood and superpower to create innovation, experts assume that we will definitely see Optimus, and it's likely that after spending enough money, Tesla will be able to create a humanoid robot with batteries, drives, and computers similar to the one that Musk described. But can Tesla do it by next year? As Musk says, of course, why not? But the hard part isn't building the robot, it's getting the robot to actually do what you want it to. In fact, robots can already navigate the world without clear instructions when they have a pretty good idea of what this world consists of. If the world is roads, or apartments, or this particular shopping center, the problem is solved by 95% already, although the remaining 5% can be incredibly complicated. But if you want to send a robot to a nearby store, then the store itself and the road from the house to it, for the bot it's an unpredictable challenge. Are there stairs and heavy doors? Passages and crowds of people? Will the robot be able to deal with unexpected circumstances and respond to everything that's going on around it? Is it safe for humans and the robot itself? Vita, even at the price of $10,000, promised by Musk, is a pretty expensive gadget to risk. No one in the world has yet managed to resolve these issues. And here, Tesla Bot could face the same fate as Honda's Asimo. He could be nothing but a beautiful demonstration forever. What do you think? Let us know down in the comments. Don't forget to subscribe, hit that notification bell, and don't miss any new episodes from the world of robotics and high tech.